The things are changing post-COVID. Big hospitality industries, big manufacturing industries are facing trouble. Hospitality industry is in doldrums. Nobody is going to attend the big functions. Nobody is going to attend big marriages or big televised games like IPL and other things. There will not be many more jobs in manufacturing industries because they will try to cut down. The only industry which is going to do extremely well is the electronic industry. Like, instead of doing big seminars in big halls, we are doing it on mobiles. The people who will get jobs, manifold in electronic industries, because almost all will be delivered by electronics. Therefore, you should give more importance, putting more on your brains, be electronic savvy. If you do that, there will not be any shortage of jobs, of recognition, and manufacturing industry, be it a software or a hardware, will increase manifold. Already companies are thinking to shift into India from China and other places because we are brainy, we are cost effective. Therefore, in electronics and electronic industry and people like you who are interested in electronics are having much better future. Thank you.
Thank you, sir. Now, I would like to invite our principal, Dr. S.K. Naveen sir, to address the webinar.
Good morning, everybody.
Good morning, sir.
While it is drizzling at many places and monsoon has almost set in, I welcome you all in today's webinar on understanding data science, applications and employment, organized by the Department of Electronics. I, on behalf of myself and Nabira Mahavidyalaya Katol, extend a warm welcome to our guest speaker, Mr. Vijay Shantagiri, data scientist and CEO Analogica from Bangalore, and all participants across the nation. Our chief patron, Dr. Raju Deshmukh, President Shikshan Prashadak Mandal Katol, and all honorable office bearers and members have been our inspiration behind all academic and other activities in the college. And development of our institution of higher learning at Katol. I feel assured that the plenary speech of Mr. Shantagiri will help you understand the importance of data science in today's context. You can resolve your queries, if any, in question answer session. I would like to congratulate Mr. Bahade, Head Department of English, and Dr. Adil Jivani, Professor Atul Cherde, Professor Praveen Revatkar, and all his team members who have done a lot to make it a successful event. I sincerely wish that today's webinar is a grand success. With these words, I would like to give a close to my voice. Thank you. Thank you very much.
Thank you very much, sir. So, I would like to request Mr. Vijay Shantagiri, sir, please begin your talk.
Thank you, sir. Thank you for that magnanimous introduction. I was shocked listening to my own. So thank you so much. It is really welcoming, and it's so encouraging to see so many participants from across the nation, and it's really innovating, and it engenders a feeling of positivism for me to be here today to share whatever I've done. So with your permission, Dr. Adil sir, may I share the screen? I'll go ahead and share the screen now, sir.
Yes, sir. Yes, sir. Sure, sure.
Is the presentation visible?
Sir, presentation is visible, but your voice is breaking, sir.
1 second. How about now, sir? Little better?
Now it is better, sir.
Okay, sir. So I'm Vijay C. Shantagiri, and presently the CEO of Analogica.in, and we are about 1 year into training and certification vertical for emerging technologies. Earlier and even now we've been in connection with many agencies who are into software development pertaining to data science and machine learning and predictive analytics, as you call it. So it's a very vast field, and today we are going to go and understand what is it all about in a very deeper and simpler way. Okay, so firstly, I would like to, as I usually do in our webinar, I would like to congratulate all the frontliners who've been fighting for this COVID situation, and I hope everyone is safe and practicing the right disciplines to keep yourself safe and your family safe. So basically, the idea of this webinar is to understand what is it to transition into data science for a non-IT person. For an IT person, it is sort of straightforward because they've already done one element right. We'll talk about that. But for a non-IT person, it is sort of a big challenge. As you can see in the image, we can see, somebody is trying to jump careers from past to data science, whatever the past be. They're trying to jump careers. And the biggest hurdle that you can see that I've put over there is programming and statistics, right? So today we're going to go into that journey where we'll understand in a very fun way what it is and what are we trying to understand. Let's talk about jobs, data science jobs in India, right? You can see the spending that is going to come about in data science in the future. Just have a rough estimate. $98 billion will be spent just on artificial intelligence systems. That is incredibly huge. You will understand in this webinar why is it so. It's not just a number. People are putting efforts day in and day out to project what kind of spending there will be. And there is just one answer where the world is moving, where the future is going. It is data science. It has to be data science because our life has become data science. What are we doing during COVID times, locked up in our houses? We are consuming data, we are generating data. Data is our representation. Data is what packages a frame. It's a frame for our behavior and activity. And data science is boom right now because it is everywhere in your apps, in your TV, in the serials that you see, everything, everywhere is data. But it is not so that it is a recent discovery or just about 10 years down the line, the buzzword of data science came in. It doesn't mean that data science or AI or machine learning, all this has been just around for the last 10 years. Data science has been from such a long time and been used in different contexts. We're going to learn about it as we move to the next slide. So just before I go, I would like to say data science jobs in India right now unfilled, roughly about 1 lakh. And the median salary of data scientists, I'm not saying mean salary, it is a median salary, roughly about 15 lakhs per annum. And still 1 lakh jobs are vacant. So you can understand it is not a job where people get hired easily. It's a very different kind of discipline, a multidisciplinary culmination of skill sets. And we're going to understand today what are those skills, how do they achieve, and why are they important, right? So just for the rough estimate that we do, for a non-IT person to transition into data science would roughly take about 9 months. And it is ironic that 9 months is also the same amount of time when a baby is in the womb, and by the time the baby comes out, it is 9 months. Somehow, we were just trying to understand what kind of time frame would you look at for a perfectly successful career transition. And it turns out 9 months is roughly about the time where you'd be comfortable from non-IT to data science. It's a long journey, but it is really worth it because that's where the situation is, that's where the future is. And it's right for us to be there. So I would like to talk about sort of how although Sachin sir has already briefed you, but a little small extension of how I became a data scientist, which is something sort of, where we start from, we get a kind of context for the story. So it would be nice if we just go and brush up or just touch the base over there. So I used to work as a systems engineer, space systems engineer to be precise. And of course, as everybody dreams of, I started with electronics and communication and then was very much interested in physics. And it was a personal connection to be with mathematics. And although I'm not excellent in mathematics, but the curiosity to understand and connect the dots and solve the puzzles was as average as everybody in India or the world or everybody from science background is. So I started with that, and mostly my work was connected to what we call C4ISR. So it stands for Command, Control, Communication, Computers, Intelligence, Surveillance, and Reconnaissance. So to be precise, my work was related to computers, intelligence, surveillance, and reconnaissance. So when you talk about intelligence, surveillance, and reconnaissance, surveillance, reconnaissance, right? So these three elements perfectly and very much so defendably depend on data. It has to depend on data. But data generated by what? Everything is generating data. But there are even bigger elements, bigger assets like satellites, like your ships, warships, communication ships, aircrafts, tanks, and you can just name it, every element that is used. Sir, I think many people are raising hand. Would you like to address somebody, or maybe some people have any issues with the voice or volume?
No issue, sir. Go ahead.
Yes, sir. So while I was working with this, I worked with a software called Systems Toolkit. This software is something which packages the concept of spatial temporal information systems. So it's quite easy to map the idea what I'm trying to tell you. Word looks big, okay, but as it is, everything looks big unless you understand the whole thing, and after that it becomes simple. That's how it is, okay? So let's look at it. Spatial temporal information system. In fact, I would say all of data science could have actually been called as spatial temporal information system. Once you understand it, you will really understand why I say so. Spatial is all the data, all the knowledge that comes from things that are put in your three-dimensional coordinate system. Everything is moving around, my hands, the images, all the spatial data. And then temporal is everything that makes sense in the realm of time. Something moves from this time to that time, that data of where it moved from, what position to what position, and what time to what time, what was its orientation, everything, all of them put together. That data completely streams. And this data could be from anywhere, all assets, doesn't matter. So while I was doing that, so it was apparent that when you have to take that kind of data and do the essential, what is that essential? Automate. Nobody is going to sit there and somebody is going to call you and you keep on typing into Excel sheets and keep making racks and racks of those data. Nobody is going to do that. Right? The world has changed a long time ago. Everything is automation. So we need systems which is going to automatically take that data and put it in a context where the data scientists can use it. So we were doing that. Our work was to be able to take that data and make intelligent decisions on the run. So for me, as a personal interest, I was very much interested in real-time analytics. So I was there in that field. So after a while, I went ahead with a startup, and with the startup came some investments, and the investment came with a product, and the product that we developed was called Remote Sensing Toolkit. Okay, remote sensing. So what it had was it had all the information of all the satellites in the world. That was the prerequisite. And there are places where you can get all the information on satellite. It is a licensed system. So we got that information, but our work was to be able to put all that data to use. Use where? So we know what satellites do. Satellites have images. Satellites have imaging devices on it. So satellites are going to move across. And what our software would do is it would tell in precisely what time and what space which satellite would see what area on the Earth. So there are a lot of applications. There are a lot of buyers for this. So with that, I thought, yes, maybe this kind of application would be applicable even for defense, right? I thought, yes, maybe even our defense could use something like this. I had a very good case study, very good story. So I just jumped in and I went to one of those very prestigious army establishments whose name I cannot take for, of course, classified reasons. And I went there, explained it on the phone. I knew nobody. There was no reference. It was direct go in and take a chance, right? So I went, I took a chance, I called somebody and explained to them. I sent my card, right? And they verified, and then they gave me a meeting. You won't believe, they gave me a meeting, not inside, but in the parking. Okay? But of course I knew, because I respect that. That's a good protocol to have. So I respected that, and I stood. The gentleman officer who was interested in understanding what I had to give, he came outside, and while he was going for lunch, said, okay, I have like 10-15 minutes. Let me meet in the parking space. If you can, we can talk about it. So I was with my laptop. I was showing him all this software that we are doing. He was interested. Next day, he took all my identification card and everything, and he gave me a pass to come inside. Right? So we went. So when I went there, I had high hopes that, okay, we have written a great software and just we are in and we're going to impress them, blah, blah, blah. He was interested, but then he said, We don't need this kind of software. What they required right now was something totally different. Until then, I was in my own mind. I hope you can understand how my mindset could have been from being totally from space and difference and doing all of this work. I thought what I am doing was like the best and that is what everything is and stuff. But the reality was different. And the officer gentleman who gave me an opportunity to meet him in his office, he told me something very interesting. He was sitting with a pile of files in front of him, and he said, right now the most important problem statement that I need to be solved is I require a software which can go deep into all these file systems that you're looking at and mine the data, collate all the data intelligently and flag them into a context from where I can predict the future events. It was a big ask. Okay, so we had to take pages and pages of digital information, which used to be roughly about 100 GB in one batch, 100 GB of Word document. Can you imagine? That much amount had to be mined, indexed, and then wherever there was a certain event 1 which happened with another event 2 and another event 3, all these events have happened together, find out the areas where they have happened. These were the kind of questions. So we did that. We did write the software for FlagX to create exactly what we wanted. And while I transitioned from remote sensing toolkit to FlagX, that is when I evolved into understanding data science. But what happened with me was I realized that I've always been doing data science. Half of the work has always been done. So it was just putting a new context to it, right? So for me, as I told you, so that is the reason why I like explaining to people why it is both easy and hard to achieve that transition. It is easy for those who realize how important it is. You're understanding? It is easy for those who realize how important it is to be in tune with what is going to come. It is not simply because it's not simply that you see ads on the TV all the time, ads everywhere. If you just search once on Google about data science or machine learning, you're going to be bombarded with the ads related. Why? Why are people behind it? Because there is a reason. The world is changing. Like I did. You understood the whole context. So that was my story. And some of the things that we did was take all this information, given information, and we convert it into numbers. So what we call here, what we call this event is converting quality into quantity, right? You bring a quantitative measure to what was quality, which was expressed in form of text. So it's a beautiful thing. Once you understand it, you'll see the magic. With that, we could do many things. We were happy, and then that's the story of my transition. So, of course, as we know, this whole webinar is about what is data science and what are its applications and what are the employment chances and what are the skills that you require to achieve or have or evolve with. So let's look at a rough estimate, just a bird's eye view before we start. Let's understand the broad spectrum where we are. The whole idea of machine learning is centered around 4 concepts. Sachin sir? Sachin sir?
Sachin sir, are
Yes,
you
sir.
there? Yes.
Yeah. Is it visible, the presentation?
Yes,
Yes,
sir.
sir.
Perfectly
Yes, sir.
visible. Perfectly visible.
Okay. There is no cut or anything in the.
No,
this one, right?
nothing, nothing. Perfectly visible, sir.
Yes. The whole context. Sorry for the break. Just wanted to ensure that everyone is on par with what I'm saying. The context of machine learning can be understood with these 4 circles in which certain texts are written. Right now, for the people who have not understood or not into this field, you might feel a sort of alien feeling to these words. But let me attempt to make it quite easy and intuitive for you to grasp it. Machine learning is about machines learning. But where do they learn from? It has to be math. It's not magic. Nobody's sitting there and giving it some advice. We are not creating anything of magic there, right? It is mathematics, very smartly used mathematics, and that math is dependent on data from the past. So without past data, there is no learning. Without past experience, somehow you have to take up all this past data in a very quantified, numerically expressed fields of numbers, and then build models, machine learning models. And while we do that, the whole idea of whatever we do comes under 4 classifications. One is supervised, another one is unsupervised, and something sort of half supervised or semi-supervised learning, and something called reinforcement learning. Broadly 4 categories of machine learning. Supervised means you will give them the data, you will give the model all the data, and you will also tell that this particular column is, for example, age, and the next column you see, for example, is the salary. So you are not just giving numbers, you're also giving what is the meaning of that number. Doesn't mean that a machine is going to understand it, right? Machine is not going to understand that it is an age, but the context in which the answers come out is more understandable because you put the context in. So it is purely called a supervised learning. You are supervising all throughout because you are in control of the data, because you have made a controlled experiment to collect that data. For example, who's doing a controlled experiment collecting your data? Every time you use a free app, there is a controlled experiment of collecting exactly what you're going to do. Allow use of file system, allow use of camera, allow use of microphone. When you allow it, you are allowing all the free apps to collect data. So they know what this data is, what that data is, or what some other data is perfectly. When you know what the data stands for and use machine learning, using past data, that is supervised learning. Similarly, when you just have data, but you don't know which data it is, where does it happen? Most relevant or most relatable example for that would be data which is coming from outer space. We have sensors, we are able to sense, we know light is made up of it's an electromagnetic spectrum, and it's a part of the electromagnetic spectrum range which has a particular frequency and wavelength, and we have sensors we can tune to receive all kinds of data. But wavelength comes also with certain kind of data in it, but we don't know what the data is. Nobody is labeling it. So when nobody is labeling it, you only have numbers in front of you. You don't know what those numbers are. You'll have many columns of, let's say these are headings, and you'll have columns of data, okay? And these headings, like if the same thing was there with supervised, you will know it's age, salary, education, blah, blah. But in this case, you don't know what it means. Just numbers. So when you have these kind of things, there are mathematical trickery, mathematical concepts based on statistics, which you will use to still be able to derive intelligence out of that data. You will not know finally what that data means. Also, yes, you can actually get the insight and know by the behavior of that data what it could be, right? What kind of nature could it be representing, whether it is coming from a pulsar or whether it is coming from a supernova. Many things are there outside, right? So this is sort of in a discovery mode. You're in a discovery mode. A culmination or a sort of a patchy work between unsupervised and supervised together, right? If you take a little bit of here and a little bit of that together and you mix and match it, then you have obviously something called semi-supervised learning. In every pure field, you take two things, mix it together and try to give a new idea, and it's semi-supervised. Because you have half of the data you know, half of the data you cannot know. So you are in a feature discovery mode, and there are a lot of aspects to it. But having said supervised, unsupervised and semi-supervised, all of these, all three of these, they may work on real time or may not work on real time. Maybe you can use it in real time systems, or you may use it with non-real time while you first collect all the data and then try to generate intelligence, right? However, this particular reinforcement learning is always for real-time decisions. And this is the hardest part. And this is the part where the future about roughly about another 10 years is my prediction, that all your AI, machine learning jobs, everything, the superior ones will end up with reinforcement learning. And if this booms, reinforcement learning is where a lot of money and a lot of investment is being put right now, because they know they want to be in the space when things start happening. So this reinforcement learning is where you can see robots moving automatically, real-time decisions, automatic cars, self-driverless cars, and learning tasks on its own. You are not explicitly defining the routes. The machine, the algorithm itself is evolving, and the way it is being done, the way it is being set up, the whole problem, that is what is interesting, because that is where the future is. And many people argue that if this goes, then AI will take over human beings, and there are many camps. One camp is from Elon Musk, another camp is from the side of Mark Zuckerberg, and they both have their own way, and there's a big divide between people as to what will happen. But that is a question for another totally different kind of debate. Right now, let's get into it. What kind of, as I told you, what kind of future is there for the wannabe data scientists? What kind of employability is here? So as you can see, broadly you have categories like this: big data engineer, machine learning engineer, AI engineer, data analyst, data product developer, and data scientist, right? So, and you can see here the bifurcations that I've put: orange, blue, and light blue. So the blue one is the median, or mean if you would say, and these two are +1 and -1 are the standard deviations. So that much standard deviation is there into the lower spectrum of the salary and the higher spectrum of salary. So roughly about lower spectrum of salary, you can see as an ML engineer would be roughly placed at around 12 lakhs or 10 lakhs in the beginning. So the lower spectrum is, the orange one means fresher, the blue one means slightly more experience, 4 years plus, and the light blue one means about 10 years. So how did I express that? I expressed it in terms of its standard deviation. This is statistics. The whole idea was expressed in colors and some symbols. If somebody understands statistics, I don't even have to explain this. The moment they look at it, they'll understand, okay, this is what they're talking about. So now you understood how data was represented. So part of data science is not just about mining data, but also to be able to represent it. So that the stakeholder, like you and me, today we are stakeholders. Why? Because you are interested in understanding this, I'm interested in and making you understand this. So we both together are stakeholders looking at this diagram, and now it is making sense. I'll just explain to you how to make sense, right? So there is also a division that just rough division of what kind of people go into data science practices. So roughly based on our poll and other polls and the data that we gathered, about 42.5% of people who become data scientists are directly from IT. Okay, it sort of feels like a natural transition for them, but it is not so natural. It has one hurdle, that is statistics. So for an IT engineer, data says 42% out of every 100 who become data scientists, you will find 42 people are from IT. And ENC, electronics and communication engineers, come next. About 22.5%, although they don't know much of programming, but their capacity because of the exposure to mathematics. So it is not digital mathematics that I'm talking about, it is analogous mathematics. It is the calculus, the linear algebra, and numerical methods that you study, those probability statistics. Statistics, I don't know, maybe you have a little bit of statistics in engineering, but the intuitive understanding, the payment, the structure to understand it, and the comfort you have with those equations are already there, sort of a much higher level with ENC. So that is why you can see half of them, at least about 22.5% of people, doing very well with a great transition time into data science. Now, business and finance also. So you can see, I'll tell you, from IT you come with, naturally you will have programming knowledge. ENC, naturally you will have mathematical knowledge. Business and finance, naturally you will have statistics knowledge. Mathematics graduate, of course, they bring math, which is the core. And mechanical engineers also bring math and visualization. Because mechanical engineers may be not into programming or much of, it's a different kind of math, structures and forces kind of math, but still they are tuned for visualization. So everybody, I'm not saying these are all the only people, from law, from arts, from some audio engineering, you will find people from everywhere. But rough estimate is this one. Everybody has something in them which helps them achieve data science. Because data cannot only be from one domain. Data is from every domain. If it is from business and finance, of course the business and finance guy will know what the data means. Simply without knowing what each field actually represent, you cannot train a model. Maybe an ML engineer or data scientist can sit together, put together an equation. But if you don't know the domain, you don't know data, right? So with that, let's dive into sort of more story-like evolutionary understanding from the beginning of how information has boomed throughout evolution. What is information? What is data? How we evolved to understand it. Very quick insight. So I call this transition, or call this whole phase that I explained, is from Big Bang to big data. How did it happen? Right? So from Big Bang to big data, of course, this is the point or the theory or the most accepted theory that universe would have started at a singularity. It's called singularity, where there was no time. So time was equal to 0. Okay? So it's a point of singularity. So the whole world or universe was created And some point in time, a thinking life form evolved. That thinking life form is human beings. So with that, the evolution happened, survival of the fittest, natural filtering happened, and eventually this structure of the brain found itself suitable to procreate and populate the world. So while an ape became a man, we had the first problem, the problem of counting. How do you count? What do you count? So when a man started settling in, the first thing when you settle is to have a habitat around you. Ensure food is in abundance. If you find there is a lot of food for a long time, you decide that let's put a hut here, let's start a civilization. Started. And of course, as you know, you have to, when you start rearing all the domesticated animals, you're going to build your own system, your own farm and stuff. So earliest man did not have any idea of numbers. But still, life had to go on. They had to have a system. So they did have an interesting system. From a book on anthropomorphology, there is quite an interesting way in which it said they used to do the counting. For a person who's guarding the farm like this, it is important for him or her to make sure that he knows how many cows or how many sheep he let out in the morning and ensure that all of them have come back. Otherwise, he's at loss. If you don't know counting, you're lost. You're at loss because you don't have a control on what is happening. Without numbers, they used to do that. And it was very tricky. It's a very interesting thing I would like to share. That all they used to do is take a few, pebbles in their hand. Pebbles means chota, small stones that you have. So they used to take that, and they used to, in the morning time when the cows used to go out, they used to take few number of pebbles in their hand. They will no counting. Simply just grab from ground, wherever you have pebbles, just grab it, okay, and stand in front of the gate and allow one by one the cows to pass. Once there is a cow which passes, you just transfer one pebble into the other. So there is no system, but there is still a system. So as and when a certain number of cows went, you have on your left hand or left palm exactly those number of pebbles, mapping it with the number of cows that went, right? So look, it's a physical information, right? So that physical information you would hold on or tie up to somewhere and keep it. In the evening, he expects all of them to come back, or somebody to go and bring them back. And in the evening, how do you check? After everything goes in, just make sure that all the mapping is done, right? So even without a number system, there was intelligence. So intelligence evolved, and with intelligence, the representation, please understand, representation of information also evolved. And the first evolution, the breakthrough, came with number system. So people started understanding that we cannot do with these pebbles all the time. It doesn't work. Some smart fellow realized a new system where you would use one symbol and another symbol like this, another symbol like this. So represent something in the world in a very uniform way where the difference is only one between every symbol. So as and when we got to that, and also another great Indian mathematician of the about 400-500 years ago, gave the number 0. So can so I would like to ask the crowd, could any one of you actually type into your this one chat and tell me who that was who gave the number 0? Now it's an open question. People can just type in. Let's see how many responses we get.
Sir,
Yes,
we have disabled chat box. They can type in question and answer box.
Okay. Yeah.
Okay. Yes.
Anyone wants to just type in the Q&A box, please let us. You can take your time, not a problem. So while you type that, I will go ahead and start explaining the next problem that was predominant. This I will leave. Yes. Was it Aryabhat? Great. Thank you for the answer. So now imagine there was a necessity for ones and the twos and the threes. Yes, because it is important, because you see those problems in life. Why did Aryabhatta think about creating a number 0 which represents nothingness? So that is the level at which an Indian mathematician would think. So make note of it, right? Not just the level of abstraction, the level of philosophical abstraction in terms of thinking that Aryabhatta realized. Make even 0 as a number, because he thought nothingness is from where you should start, and nothingness should be represented as a symbol in our mathematical system to make it a complete system, right? So just, this is off topic, but I just wanted to make sure for people to understand what a great achievement it is. Now, coordinate systems. What happened with coordinate systems, and why are we discussing about coordinates? This is a very important aspect that we have to understand. Let me just get the canvas off for it. The next problem statement that was predominant is, once you know numbers, once everything is fine, now trading happened. In civilization, people started trading with each other. You are here, you have a market, okay, after 10 or 15 kilometers, somebody else has a nice seaside, so they have fish. Somebody else is in the hillside, so they have wool, right? For every season there is trading, and when you trade, you need to travel. When you travel, you need a reference system. So understand why it was important to have a coordinate system, because you needed a reference system to travel. So this was the basis of people understand why should I study mathematics? Why should I do this? Why should I do that? Right? So many things are there, but not everything has a direct relation to the observable and tradable world. But most of the earliest inventions, earliest systems that came in, has direct reference to our existence. And one of those is the idea of coordinate systems. Okay, so people like one of these earliest propagator of this idea, and under whose name you call Cartesian coordinates, Descartes. René Descartes gave Cartesian coordinate systems, and it's a very uniquely and generally acceptable system that you have an x-axis and you have y-axis. You label certain axes, and each of them again is a number line. Whatever numbers we had earlier, 1, 2, 3, now your numbers came here. So I'm going to connect with you slowly. For non-IT, for somebody who's not from IT, slowly you'll understand how things are changing, how observation, which was just about information, how it has slowly started to become information. Data will become information when you put the context. For example, some trading happened, you walk from this particular 2,2 point to next some -3 to 3, and then move from there, right? So you have numbers representing. So when every intelligent human being can understand single reference. The exchange of information or exchange of data is actually the information. So with that came the next level of problem. That is the smoothness of curves. So with all of this, when trading happened and you needed a system of trading. So the first problem that was faced was when they were trying to calculate area, right? Area of any place, area of a place, area of an object. Something which is two-dimensional, something three-dimensional, doesn't matter, but area. If you are given a straight circle or a straight circle, a straight object made of straight lines, like a rectangle, if you're given this, it's fairly simple to just calculate it as length and breadth and have an area as L into B. Makes sense, right? Length times breadth. But what if your area looks something like this? Of course, you can use a rope and calculate it. But we don't want to use a rope. We want a system of mathematics to use it. So how do you calculate? If, let's say, I'm going to draw something in between, like this. Let's say I'm going to draw this area. It looks difficult to find the area of this, but still not so difficult, because you can always put a line here, you can always put a line here, put a line here, put a line here, right? You can convert this into what you already know. You already know how to calculate area of triangles and rectangles, right? So obviously you will just know, you will measure it, and that's it. You know, you will add up all of this. So you reduced a complicated problem to a problem that you already know. But how will you reduce this? That is why we call it the smoothness of curves. You have to tame this smoothness. It's like this. How many divisions are you going to make? These divisions that you're making, they call it the differentials. So this gave rise to differential calculus. So the whole idea is area under the curve. Okay, that is what calculus is used for. So the same calculus is used to model or derive the machine learning models. Because if some machine has to replace human intelligence, understand that you have to take digitalized, quantized numbers and take the quantized numbers, use algebraic principles to grow a function and use calculus on it to predict where the growth is going, right? This is how, in short, if you want to see, this is how it works. But I also want to bring just to pay tribute to the whole explosion of data science that happened, because now I'm shifting directly from smoothness of curves. This was roughly about Newton. Newton was also from the same time, 1600s, of course. So 1700s, I guess, Newton. But here's Tycho brain, and arguably there is again many camps. People think differently, but I also think that arguably is the greatest data scientist actually ever, and he lived in 1600. Now you'll be wondering, what is this? Like in 1600, about 400 years ago, there was somebody like doing data science? Yes. In fact, the entire beginning of astronomy foundation was laid by Mr. Tycho Brahe's great work of collecting all the observations. He was a master of building accurate instruments, and he spent his entire life collecting data points of what he's observing. He made tons and tons of pages properly organized of what he's observing. The purity of data that he collected is a big name. We don't know. Okay, even for most of the time, even when because I studied astronomy and space engineering, so it was my business to know it. But even then, back then, when I studied astronomy and space engineering, I didn't know that Tycho Brahe could actually be called one of the greatest data scientists, right? Only recently, when I was understanding from another video, I understood like, yes, this person's work is so amazing. So he collected all the data, but he made one flaw that he had. He thought, his idea was not heliocentric, but he thought Earth is actually at the center. He believed in it. So he wanted to take this data and fit what he thought was right. He thought Earth is at the center and everything else is moving. So one important thing in data science, you may have amazing amount of beautifully collected data with you, but if you go in with a biased mind, you will not get a prediction. So you should go in with a clear mind. Although greatest scientist of all time could be for his collection and for his purity of collection for years that he collected, but he had a bias in his mind, right? Who cleared that bias? Who cleared the bias? His student, and his name was Kepler, right? So Kepler was his direct student, and eventually all his data was given to Kepler, and Kepler, of course, as we all know Kepler's laws of motion, and everyone who's in science know that he was the one. So you can see here how calculus is exploited. So he discovered. So data gave rise to your fundamental laws of physics. Nobody was there to give insight. No supernatural alien came and gave these people the idea that this is how the universe is working. They collected data, they matched the numbers, and they evolved with it. One of the next beautiful thing that happened in about 1860s is, while all this happened, physics gave rise to mechanics, then optics, and all of that moved to electronics. Roughly in 1920s, by 1920s, there were vacuum tubes research on it, right? In 1920s, they got the idea of electronics. Trust me. I mean, just hold this thought. In 1920s, but by 1860s, binary numbers were already given out as a paper from George Boole. So he converted all your numbers, representations, 1, 2, 4, 5. That we don't need so many symbols. Give me just one symbol like 1, another symbol 0. With just these two symbols, I will express all the numbers possible in this book. And the beauty you have to see is George Boole didn't even know that about 80 years later, somebody is going to come up with an electronic vacuum tube on which you can hold information in terms of ones and zeros. He didn't even know. This is the beauty, right? This is like chance. When you look at it, like, how did it all work together, right? So with that, the explosion happened, and these ones and zeros being represented by electronic circuitry now became small memory chips. So now memory chips can hold data. And with this, on this memory chip, they started building the firmware. And on that, you start building operating system. And operating systems has an application layer. And all the software that even you are looking at, the zoom, the motion of my mouse, everything is playing here. And because of the speed at which our systems are working right now, you can hardly see the difference from where the apps move from the OS moves to firmware, the chips, the data gets transferred between each other without even noticing. You see me directly speak. That's the power of computation. And when you combine the power of computation with the data and the knowledge to exploit that data, now you start feeling what can be done. So when somebody says data science is the future and it's going to make lives beautiful and easy, what we are trying to say is we know the future engineers are going to be more equipped with better tools, sharper definitions, and better team structure and guidance and mentorship to be able to create amazing amount of machine learning applications. It's just a beautiful rendering image of how much data we are producing, right? So you can see the main data production centers from here: the weather, the Jiffy, the Netflix, Snapchat, LinkedIn. WhatsApp is not here, but it should be, right? Twitter is generating. All of us are together trying to generate data, and that data says something about us. We need to understand how that data is exploited, and we're going to get into that right away. Okay. So this is a small representation of how data evolved. Why I want to show this to you guys is machine learning is what we are talking about. There is an extension and much higher level of predictive analytics called deep learning. And deep learning is based on the neural structures of the brain. And those,
excuse me.
there's a disturbance.
I suppose it is breaking.
How about now? Is it smooth now? Sachin sir, is it smooth now?
Yeah.
So is it? Are we audible now? Am I audible?
Vijay sir is reconnected.
Yes, sir. Sorry. Is it? Am I audible now?
Yes, you are audible now, sir. Okay.
Some packet drop, I guess. So.
No, it's okay, sir. Please continue.
Okay. So I was saying that machine learning is a recent activity and something somewhere where in India lots of jobs are there. Deep learning is something which is looked at as an advanced form of machine learning. But it is based on the idea of neural structures. Okay. So now just look at this graph of evolution of what happened through the years. Neural networks, the idea of the first computational unit, which was structured on the idea of brain, came in 1943, given by Maclow and Pitt. 5 years later comes the mathematical theory of communication, which is the basis of, if you are from electronics, and wave theory and the sampling frequencies, all of that, the idea of came 5 years later, 5 years before Shannon gave the electronics fundamental theory of the electronic waves and communication channels and how you sample those frequencies and stuff. 5 years before that, neural networks happened. So that's how long it goes, and people are. What happened now is suddenly we have all started using our smartphones, which becomes the machine which generates a lot of data, right? So now, after having understood all of this, the question begs itself to now let's start about understanding what is a machine learning. What is it, and what? So I don't know if many people would have already done data science, or if people are completely new to this. So I would like to sort of give an example to make you understand how does a fundamental machine learning model looks like, right? So I'm going to give you an example. I'm going to ask you to engage with me and think of a model. Think of this model as a gun. I'm very bad at drawing figures, so I'm going to just assume that this is some sort of gun. Okay? Or let me see. Let me see if I can quickly get you. There you go. No need to assume you have. Think of this as a gun. This gun generates data points. Think of it. This gun is the model and it is generating points or data points. Now let's try to build a model like this for an imaginary problem. I'm going to be very straightforward getting into machine learning, the idea of machine learning, because unless we see it, we'll not connect it. Let's define a problem for ourselves. Okay, let's define a problem for ourselves wherein, let us say, we want to predict is the word. Okay, we have come to now mainstream. Predict the real estate price. Or in particular, let's say we talk about the Nabira, Mahavidyalaya, wherever places. What could be the price if somebody wants to invest on it, or a place like that near your college or university? What could be the price 5 years later? So if he or she who is an investor wants to understand whether it is a positive investment or not. So what do we need for that? So let's say we have a smart real estate guy who wants to build a system like this. Now, he will go to the municipal corporation of Nagpur and he will ask, by the Right to Information Act, I am authorized to get all the data, real estate price data from 1950s to 2020. 70 years of data I want every year. I want to know what was the price of the place, the area, which is now the Nabira Mahavidyalaya, the cost of that in 1950 to 2020. I hope it's an example because I want to be personal with the idea, right? So that you can connect with it, right? So somebody wants to invest and want to see, invest in this whole enterprise. So they want to see what is the worth and what is going to be worth in 2025. Now, how does mathematics or a model, how do you build a model for this? First, you need to collect data. So let's say the municipal corporation or whoever is in charge of that data gives this man, okay, take 70 years of data, every year the data is here, how much ever the cost of the price was in that area. So we start plotting it. Where do we plot what? We'll plot time here, we'll plot price here, right? The time is now divided into decades, right? So we can sort of have a half decade. A half decade is every 5 years. 1 unit is every 5 years, okay? So we can sort of call it the first fifth, the second fifth, third fifth, right? So you can represent it as A, B, C, D. The ABCD should be here first. we start with 1950s, 55, 60, 65, 70, 75, 80, 85, 90, dot, dot, dot. We have until 2020. Here you have certain prices. Let's have a rough estimate. Let's have a rough estimate that 1950s, maybe the entire area of the university or college where it is, maybe it would have been around 10 lakhs. In 1950, 10 lakhs was huge, right? So as it increased, maybe it became, next year it became 12 lakhs. And after that it became maybe 15 or maybe 20 later, right? See, go start extrapolating this and just, we are not predicting. This is just what data you got. We are not assuming anything. In 50s so much, in 60, 55 so much, you have a data with you. Let's put it all together, right? 20, 25, 30, dot, dot, dot. Somewhere around this time round, you will be looking at how much? Any guesses now as to what in 2020 could be the cost? I don't know, maybe I would say roughly about 50 CR. Okay. I don't know the place, so I'm giving a rough estimate. Now, once you put all this data together, now is when the model building starts. So we have, we'll call it x-axis and we'll call it y-axis. Now we want to build a machine learning predictive model who's supposed to tell us what is the cost of that particular real estate in 2025. So in terms of that, it is we have this 1950 and 55. We cannot put this data right just like that for the system to understand. I told you, this was the first decade. 50s was the first decade, 55 was the second decade, 60 was the third decade. So we are going to name it 1, 2, 3, 4, 5, 6, 7, because this now is the decade number, okay, or the half decades. 50s is the half decade, next is the second half decade, like that we are going to name. Hope you're understanding the decades, right? So between 1950s was first, 1955, between that there is 5 years gap, another 5 years gap, another 5 years gap, like that. You have by 2020, maybe you are talking about 90s to 95, 2000, again 1, 2, 3, 4, another. So roughly about 13th decade or 13th half decade belongs to 2020. So you have a number system which exactly now intelligently for us, it gives us a representation. Now using this new representation, we are going to build a model. We're going to come now to the main field. We have all this costs of it. 10, 20 goes to 50 crores. And we have the first half decade, second half decade, third half decade, fourth, dot, dot, dot. It goes to until 2020, which is the 13th half decade. And our contention is to know what happens in the 14th half decade, which is somewhere you want to predict where the price is going. What do we have now? These points. Because we know a first decade was 10 lakhs. The second decade was around 14 lakhs. So we're going to point that. We're going to plot that data. It's easy, right? Just keep plotting that data. What you're seeing right now is actually the data, these points, because it says in the 10th decade or the 10th half decade, which coincides to 10th half decade, which will coincide to 2000. In about in the year 2000, the cost of the real estate price was somewhere about this. That is how you interpret this graph. Now with all this data, we are going to build a model. So let's find out how. So simply looking at it, this is a regression problem, because this number is also increasing, this number is also increasing, right? So we call numbers which are increasing like this, it's easily identified as a regression problem. So simple, you'll be startled to know that, okay, this is all there is to it. So this regression problem we call as model or curve fitting problem. We need to fit a curve which represents an algebraic relation. So what is the relation, algebraic relation we are looking for? It has to come out from data. What algebraic variables do we have here? The only algebraic variables we have here is a value in x and a value in y. So you need to be able to build a function between y and x. So that is the most simplest, and the ordinary equation would be equation of a straight line. What is an equation of a straight line? Y is equal to mx plus c, where m is the slope, x is what data you have, y is also what data you have. But you only have data from a particular past, like for the last 70 years. And you want to be able to predict in future as well as predict in past what could have been the price maybe in 1940s then, or what could be the price in 2050, right? So for that, all you need is a equation, and this is the model. Okay, so now going back to the gun example that I gave you, this for the model for this real estate problem, this is going to be the y is equal to mx plus c is going to be your model, and its work is what? Why am I saying it is like a gun? I'll show you why it is like a gun. Because it says you should look at it in another way. Y is equal to mx plus c is nothing but mx plus c is equal to y. So what you're doing, it says, I know the m, I know the c. You just give me the x value, I'll tell you what y is. This is what it is claiming, this model. That is why I call it as a gun. Every model is like a model which produces data according to the past data, right? Understand? So this is what it has learned. But how does it happen? Is this the model then? Is this the model for this particular problem? No. Unless you put what value c is and what value m is, this is still not a model. But how do you know what should be the m and what should be the c for this? So the particular m and particular c is understood when you can plot a line across it. Now this, suppose this line that I just drew, suppose this is the model and it looks like the model. Why? Because now it represents some kind of y is equal to mx plus c line in which most of the points are nearer. So if I tell you that no, I think this is the model which is right, would you agree with me? No, because see this, it is not following the curve. It is not a right representation of the curve. That is why this is not the right model. So we will not use it. But how did the machine learn this? How did it know? Who told you? Like, is it learning on its own, or are we looking at it and fitting a curve? It's a very simple explanation for this. When the algorithm computes that linear, it's called a lin regress algorithm, or any name you can give, but mostly used as lin regress. This is an algorithm. When the algorithm starts, it starts with an assumption. It starts with an assumption that let us suppose this is the line. It starts with that assumption. At this particular time, this particular point in time, what it does is it calculates the distance between all the points, the horizontal, direct, perpendicular distance between all the points, all of it. Okay, so more data you have, the better. So it is going to keep a track of this. Somewhere it's going to make a table. Okay, its work is, the algorithm is built in such a way that you keep all the points and how much distance there is between those points. And next, it will try to shift the position of this line. Now this position of the line can shift here also, or it can shift here also. It doesn't matter. Okay, but which way to shift? Who will tell the model which way to shift? This table will tell the model which way to shift, because our contention is to minimize the distance between this point and the line. Every point and the line should be minimized. So the moment it moves away and the calculation happens, it says, well, last time we had around roughly about 8 units of distance. You moved away, so now we have 16 units of distance. You moved in the wrong direction. So we penalize it, or we don't approve. So we said we build a program in such a way that you should move, you should consider the movement where from the past your distance decreases with time. So in fact, it is squared actually. Okay, all these distances, what I said, is going to be represented here. They actually don't simply say 8, they're going to square it. Called 64 it's going to become, right? So it is squared distance which is being calculated. Why? Because when this is getting calculated, you will also go into negative dimensions. So we want absolute value, so it is going to get squared. But still, all we require is a number. What number? A number which says whether the proposed model which you think is going to fit the curve, moving away or closer. So with that, slowly the function or the algorithm is going to keep creating and moving closer and closer. And don't think that it is going to just create a line and stop here. Okay, it might overshoot also. But again, the algorithm will make sure that no, you are overshooting, come back. Earlier was fine. So once it says it settles somewhere, then again it will start moving slowly around, slowly, like an oscillation. So first, when it started here, we give a rough number, say move by 12 units. This units, what I'm trying to tell you, is the slope. And slope means how much degrees you can move. That slope, the slope that is there, that is called the slope, right? So in terms of trigonometry, you will understand what the slope is, right? So when that happens, you will slowly come and arrive at a line which so fits the curve that almost all the numbers or all the points are closest to it. So then we say this particular line with a certain y is equal to, let's say, 0.5 as a slope into x plus some y-intercept. C is the intercept where this proposed model is cutting the y-axis. Okay, so let's say around 5. Now what you're seeing is your model. Now this model is the one which says, you give me x, I'll give you y. Now you can easily go and calculate what is going to happen in the 14th half decade, what is going to happen in the 15th half decade. Of course, 15th half decade you know. 15th half decade means from if 13th was 2020, 14th would be 2025, 15th would be 2030. So 14th you already know, which is 2020, 15th is 2025. So now you know for 15th half decade, you put the value 15 here and you get a value of y. just some appropriate value, right? So it knows what that value is. With that, you will understand exactly how this model works. So a model is nothing but an algebraic relation. So this is where I would I would ask Sachin sir now that would it be a right time for a Q&A session, because of course there are too many things I want to explain, but I don't want to miss out on the Q&A session. So just another slide where I explain what kind of job roles are there in the industry and what kind of background is required to be able to achieve that. And so if you could open up the floor for Q&A if somebody wants to ask, I'd be happy to.
Sir, Q&A box is open, sir.
Okay, sure. So I should just go and look at the questions.
Sir, there was one question earlier. One participant asked about machine learning.
Yes, sir. What question is that?
That was specifically about what is machine learning. So that was a very basic question actually.
Okay, if somebody asked that question, then I hope this whole explanation answered it.
You're
the
right,
machine,
sir, right.
The machine has actually learned now. There is no magic in machine learning.
Yes.
Okay, it has to be. There cannot be any magic anywhere.
So far there are no new questions, sir. You can please go ahead.
Yes, sir. Okay, somebody wants another webinar organized on a career in astronomy, cosmology, and astrophysics.
Yes.
I am not an authority on it. I don't think I should be doing it. But I have a friend. Who works, is very close. He studied with me in Manipal in astronomy and space engineering. I think he's even written a book. So definitely we can arrange something and I'll let you know. I'll let Sachin sir know about it. Okay. Right. So with that, let us quickly dive into. I hope now people just give me a thumbs up if you've understood, and the whole idea that you had is now clear. Whether you know what exactly we mean that machines are learning. This is it.
Sir, participants have already commented. Like nice explanation. They are getting everything.
Okay, sir. Great.
Those things are already commented, sir. Being commented.
Okay, sir. Moving on to the next slide. So roughly, let's look at what kind of job roles do you have in machine learning. There's machine learning engineer, roughly about 8 to 12 lakhs when you start. So experience about 1 to 3 years if you have, you'll directly land in a job that gives you 8 to 12 lakhs per year. That 1 year of experience that I'm talking about can be a real experience, means like you hired or you interned. So it is very important to start your career with an internship, at least for 6 months somewhere, where you sort of gain, or you know what internship is? Because internship is a time where you're supposed to make all the mistakes. Because nobody wants to pay while you make mistakes. So you intern with a company, make all the mistakes. So when you intern, you'll be paid very small amount, and some are unpaid internships, but still you gain a lot of experience. So once you have an internship, it means you've made all the mistakes and you now know what not to do. So with that experience, you can jump directly into a product company or a service company or an analysis company into data science. And what is required for a machine learning engineer? So for that, I have a slide which is more the same thing. Whatever I have here, I have put it in a broader image so that I can relate and you can also see. The programming skills required, the programming language required, Python or R programming language. If you want to be purely going into data analyst, data science, statistics side of it, then R is preferred, because R is from a long time. Python is preferred when you want to go into machine learning engineer's job, where you automate a lot of stuff and you build products, right? So more programming intensive, automation intensive, real-time analytics requires Python. And Python is the future. Because what happened, Python earlier was a programming language. Now they've added so many beautiful packages that now it is competing and even sort of replacing R. So if there is any question of what to invest time in right now, go with Python. Okay, it is highly stable and even good for product development. Okay,
there is one more question. Machine learn. You can go and checking Q&A box.
Yes, sir. I am seeing that. Yes, Mr. Salim there is asking, machine learning artificial are sister lineages or different? Okay. Sister. I'm going to answer that question by referring to the previous slide where I created a model. So you see this slide again. I have created a model. In this model, our contention was to find this slope. Okay, I hope you are understanding or relating to it. Our entire exercise of creating this model was, slope. If you found slope, then you found the model. Now, if you are finding this slope using statistics and algebra, it is machine learning. If you are finding that slope, but by not using direct machine learning and algebra, but setting up this entire experiment in terms of neural networks, where because the problem statement become very complex, so you need not one algebraic equation, but many algebraic equations working together to give the human-like smoothness to your prediction. So each of these neural networks themselves becomes a mini model, and all of them together become one major model. So when you are using machine learning in an algebraic relation, you call it machine learning. When you are using machine learning in the context of neural networks, you would call it as AI. It's artificial intelligence, right? So you can say AI first is data science, and under data science you have broadly AI. Under AI you have machine learning, deep learning, and neural networks and stuff. And then there are domains where you are using image processing and stuff. So that is kind of lineage I'm talking about. And next, sir, actually we've been learning machine learning from past few months. There are many topics, and each topic is great extent we have to learn. My question is to which extent do you think that it would be better to learn or have any idea? Because it's taking a lot of time to cover in depth, and you can suggest any good book of statistics. Okay. So you guys are learning, but to what extent? This question is from Kalamdar, MS Kalamdar. Okay, so MS Kalamdar wants to know see if I can paste it here. Okay, I'm not able to copy it, no problem. Okay, this is the question. So to what extent you want to learn? That is the question, right? I would say once you have invested time in machine learning, don't drop it, because that is the future. And the extent to which you must learn is to the extent that you can go to Kaggle, kaggle.com, or UC Berkeley repository, and be able to download data sets and build a predictive model on it. If you can do it to a certain degree, to the extent where you are using linear regression then you've used naive Bayes, then you use decision trees and a recommender system. If you use this much and then have done one project for deep learning using Keras and TensorFlow, so that at that point of time, I think you can just say that, okay, this much I've done, and most of the problem statements will revolve around this and deeper into this. So once you know this, you can call yourself that you are trained and adept in machine learning paradigm. So Shilpi wants to know, just need some guidance from you to how to use proper algorithm, how to create a perfect model for problem. So I should go through Kaggle for making projects. Okay. To use proper algorithm and how to create a perfect model. So I understand your problem. Proper algorithm means which algorithm suits what? Is that the question? Like, if you have data wherein you have a combination of both quantitative and qualitative data, means one field is in numbers like did buy a car. So you have 1, 0, 0, 1, yes, no representation. And how many cars did he buy? Another 2, 3, 4, 3. These are all moving numbers. These are all classification numbers. So depending on the kinds of data and the kind of distribution it is mapping onto, you will obviously have a sort of a map as to what is the most suitable algorithm for it. So how to know which algorithm suits best? Go into the depth of how the algorithm is built. Once you know how the algorithm functions, you will know where it applies. If you simply MATLAB, you are using MATLAB and calling for certain APIs and giving it data without knowing what that algorithm actually is doing, you will not know. For example, now you understood linear regression. Now you will not ever apply linear regression on a data which looks like this, because on one line, on one axis you have 1, 0, 1, 0. And on other axis you have numbers which is moving from 1 to a high number. How do you think an algebraic relationship can be set up between something which moves like this? Correct? This is 0, this is 1 and this is 0. And another representation, this one is like this. And one more will be like this, moving higher. How will you set up a relationship? It's not possible. So one thing, if you want to understand how the algorithm works, you want to be really adept and skillful at it, then you should first understand the nature of the data you're dealing with. What kind of features are there? How are they moving? That's why you need a sort of statistical knowledge, statistical pre-processing. I hope. And there was one more question I wanted to understand. Perfect model. Okay, to create a perfect model. Okay, now in data science or anywhere in anything related to data science, data has its sort of quality. I'm not talking about qualitative data. I said data quality. This data can be collected by many people. For example, let's say take our COVID situation itself. If an Indian Statistical Institute wants to build a perfect model and will assign all the states to collect data, then the states will assign all the districts to collect data. Districts will assign all tahsils to collect data. So ultimately, that final data is a culmination of what all the small centers collected, right? So if those small center people who are writing and collecting that data of many devices, if there is a lot of human error, right? The data that comes to you is already biased. It's called biased data or erroneous data, right? You will not know it. That's the challenge of it. What you see in front of numbers, you think that is the data, but there's a lot of human errors. So there are many techniques to identify that human error. One of that is called k-fold cross-validation. You can actually cross-validate from each sector and identify so powerfully, get the data back to the government saying that let us tell you that maybe from this point of time to this point of time, whatever data you gave me is biased because it's not fitting properly. Then that with that section, they can go to the exact tassel and say the data that came from you was all biased and wrong because it is not fitting with the uniformity of the main data, right? That kind of data evaluation is first important. And once the data is evaluated perfectly and still you're not getting the right model, then there is something wrong with your approach. But a data scientist's job is to build a model and not to build a perfect model. If you're trying to build a perfect model by trying to mess up, work around the data, then it is actually sort of unethical because the data leads to decisions and you should not play around with the data. Whatever data is in front of you, you should apply the principles properly. And if your question is about applying the right principles to get the perfect model, then the right principles will fall in front of you when you understand the principles in which the algorithm is working. Okay, so understand the principle working of the algorithm of each machine learning model, you will get the perfect model. But don't try and change the data or be selective of the data just to get 100% or 98% accuracy, because data is data. If you cannot get that accuracy, then go do k-fold cross-validation and find out what area of section of data is messing up the curve. You'll actually be able to write a better report and give it to your stakeholders saying that you did your best, you did all the tuning properly, but the data is just like that. So if I can remove this sector and that sector and another sector from the data and build it, maybe now I'm getting 97% accuracy. But if I put back those small sections, my accuracy is going totally wrong. You can tell them something happened. Something has happened during the collection of this small section of data. You go figure out what it is. You can give them a report, a kind report. This is the learned way of doing things. Okay. The development of Mohammed Cylinder is awesome. Development of any program in relation to biology, science, is done by machine learning or system management. I'm not understanding whether it's a question or a statement. Development of any program in relationship to biology, science, application is done by machine learning or system biology. See, at some point of time, you have to evolve. You have to evolve to understand the whole context of data. I'll give you a rough estimate. I'm going to connect the whole picture for you guys. But look at this. If you want to take anything away from this workshop, now from 2 hours I've been talking, I've been trying to put ideas into your mind. And let me check. There are about 76 people still sitting around and listening to me. Thank you. And hope I've been able to give you something. So if you want to summarize all of it, I'm going to summarize it now in the next 5 minutes what I'm going to say. Please listen to this carefully. I'm going to be very slow. Events happen in the world. Events happen everywhere, outside the earth, inside the body, in the machinery, in the tanks that goes to the war, in the aircrafts that flow around you, in the data that you're collecting, the movies that you're watching. All of it is an event. All of that event produces data. All of this data contains information. So when events become data, some of the events are collected directly as numbers. Some of the events need to be processed and quantized to become numbers. Finally, you're getting data. Once that data is tabulated, you start thinking that the data itself is information. But no, it's not like that. The difference between these numbers, from what number to what number this shifted, while what number to what number this column shifted. There is a relationship in the shift between these numbers. Now, statistics is exploiting this relationship. Once you understand the distance between this, you are now doing either descriptive statistics or inferential statistics. Inferential means predictive. So once you understand that, that is the transition from data to information. This is when you put it in the context of stats, information is done, right? So now coming back to the, am I still on, or the questions were retracted? So events happen in the world, data gets generated. Wherever there is data that can be quantized and put into a data field, and data field can be put into information, you can apply predictive analytics or data science or machine learning, AI, anything, right? So this is the takeaway from all this. The takeaway is events happen, data gets generated, data gets tabulated. Between the tabulation, there are numbers. For example, let me actually give you a number field so that it is easy for you to relate to. It's a little blurry, I'm sorry. So numbers data is here, but once you put the data in terms of its, see the number of calculations that is done on the data. Some data is here, it's blurry, I'm sorry I couldn't get that proper rendition or crisp data. Okay, let's look at this. Okay, I hope it is clear. So this is some kind of data, but the information actually is hidden between these numbers. What happened from 71 to 97? When it increased from 71 to 97, what happened to units? Did it increase or decrease? These increase-decrease relationships is hidden somewhere in these statistical measures called number, mean, standard deviation, reuse, coefficient of variance, P25, median, P75, all of this, years together people have understood. So this is how data becomes intelligent once you start applying statistical models on it. After you apply these, then you will know, okay, the standard deviation is so much, so it is maybe fitting a normal distribution. So for all that which is fitting a normal distribution, these are the set of algorithms which is suitable to get the highest accuracy. So that is how it is mapped. So that is pretty much how we will go about it. It's all structured now. So any more questions?
Sir, there are no more questions in Q&A box.
Okay, so I'm going to now, if people for those who are looking for a transition into data science, how do you go about it? What are the steps? Like, some people have started, some people may not have started. So I'm going to quickly run you through the issues of transition to data science for a non-IT professional. Right? First of all, it is a motivation, the problem. Then it is an assurance that for all the motivated energy that you put in, is there any assurance of you getting somewhere? Then the biggest hurdle is programming knowledge, which is going to hinder you. Then you have to cross the barrier of statistics. Then you have to understand the algorithms in machine learning. Then you have to gain some experience, and then you gain an impact. Okay, so these are roughly the broad categories of problem state. This one that you will face. Most important question if you want to transition. Thing is, how many hours a week can you dedicate? You have to know this. How committed are you for transition? You have to know this. You have to know this is all quantized values. These are all, qualitative questions for which there are number answers. Answer as number. Exactly what role in data science are you targeting? I told you earlier that there are different kinds of roles in data science, like machine learning engineer. Then there is an AI engineer. Different skill sets, same skills, programming, pandas, Python, MI algorithms, same class of skills, But how high should you know each other? Difference, that's what changes. Okay. Then you have data analyst, and this is like a sort of broad perspective of things that you require to know. If you're good at communication, you're good at statistics, you're good at programming, good at business. When I say business, not just business, this is actually representation of the domain. So if you're from a mechanical engineer domain or automobile engineering domain, then you are suited to go into AI applications for driverless cars. That's an AI. If you are good with law, if you are a lawyer, you know law, and also know statistics and AI, then you will end up in a company which is creating softwares for the future lawyers, where automatically the software will mine where and when, what kind of judgment was given by what kind of judge pertaining to this particular case. Everything will be automatic. If you're from lawyer, the domain is, that's your business, right? So when I say business, means not business like money profit business. What's your business? What's your creed? What's your domain? That's right. So based on that, there is a nice Venn diagram as to if you just are a programmer and you have a certain, if you just are a programmer, then you'll be called just the hacker. Okay. But if you know programming as well as statistics, then you're in the R core team. Then if you know programming, you know statistics, and you know business, you know what your business is, then you are a proper data scientist. So this is sort of a Venn diagram. I'll send you the link. I'll share the link with you. So you go ahead and properly analyze this. You'll get a better idea. So complete transition asks you questions. Have you chosen a mentored transition? I mean, are you going about learning from books and YouTube material and resources, or have you chosen a mentored transition? So depending on whether you've chosen a mentored transition, the time of arrival, the time of transition, or the structured way in which you go matters. How resolved is the financial aspect of transition? For many people who are already in non-IT field or working in industry, this question matters a lot, because there are many agencies, many institutes and online establishments which have range of pricing for this transition. So what is your research? What kind of research? You have to do a lot of research on where you will settle in. So now, is yours an external transition or an internal transition? Very important question for working professionals, because sometimes you will be working, for me it was an internal transition, because I was already working with data and I just started applying data science for it. But some people are not at all working with data. They don't know, they are working completely different. So for them, everything has to be taught from beginning, right? So an external and internal transition means that. And then you have to know, you have to set a timeline and say what is the exact date you will start. And once the engine starts, then you have to just keep on moving, and automatically one day you will realize that you've completely gone with it. But very important, everybody should know statistics and data science, not just to become ML engineers and get a salary or something, or a higher salary. Because the world tomorrow will become a data-driven decision making. Everybody is going to come to you to sell you something or buy something from you. If you don't have the measure of what you are doing according to the statistical tools that are available, then it's a little difficult. Because everybody is giving us some data. Everybody, 50% of this or 10% of the median value, you will find this kind of job. That explanation comes in data in terms of statistics only today. But you should be aware to know what is the truth in that. So that is life, and it has to be. You have to have it should become basic knowledge, not machine learning and building AI systems, but stats and data should be basics for everybody, and that is why it is taught in the school. But in school, we are taught just about, a problem is given and you have to just solve the steps and give the answer. But of course, when we become mature, we know why we are doing it. So hopefully you will take that path and understand it. Very important is the importance of programming skills. Programming skill, I would say, if biggest hurdle will be programming skills. The second biggest hurdle will be statistics. Statistics still can be managed, but some people we have a a huge fear of programming, and for them, it's like a psychological barrier. So we say the solution is of that fear of programming is within us. So for what I believe is that human brain itself is a reverse entropy engine. It is designed to build patterns out of chaos, any patterns out of information. You are not doing anything, right? It is our only thing is persistence. Today you didn't get back to it again tomorrow. Tomorrow maybe your neural structure is slow, but once it gets onto the hangs on to the patterns, you'll slowly get it. That's how you learned writing. That's how you learned driving and swimming and stuff, right? You didn't do it by practicing step by step. You just were told to do it every day. You did it. So the same way, programming is also like that. You just do it. Okay? You do it unless you get it. You will get it because it's the nature of the brain. Whatever you do, you will get it. Okay? So have faith in the brain and the God who has designed this brain. The faith is missing. That is why we don't know. Okay? So with that, there is, of course, we also have at Analytica, we have many programming modules. So for us, we start with phase 1 for non-IT people, where we make them understand completely. The first phase itself is introduction to computing, because just learning programming is not enough. We need a context. So we teach everything from how the binary information is processed, how operating system works, how apps exchange data, so that from non-IT people, they'll feel that, okay, they know as much as what an IT person knows, right? So when we can equate you to a non-IT and bring you on the same level, then your first fear is gone, that you know as much as a non-IT person knows. You've seen it working. So we keep removing the hurdles, psychological barriers in our courses. So phase 2 is programming. So make a note of it, because this is our brochure, but I'm showing this so that you make a note of the basic stuff that you require to learn. Wherever you learn, but these are the basic stuff that you require to learn. Basic Python is important. Python package information is important. Data visualization is important. Pandas is a beautiful package which saves time and energy of many people. This is very important. Okay, you should be too good at it, and it's very easy, also very fun. Just practice will make it. So once you're good at Pandas, then of course naturally you'll start becoming good with data pre-processing, and then you go into advanced Python when you move from machine learning engineer to AI. Okay, because machine learning engineer, this much is enough. Advanced Python is not required, but AI engineering requires advanced Python. Phase 3 is statistical analysis and mathematical thinking, right? So it is very important, as I told you, been telling you, looking at data in context of statistics is very important. So we cover that phase. Then we cover the machine learning. We go into the depth of algorithms, explaining each and everything, our quizzes, our tests, our certificates. So everything, every phase we have designed it as its own certificate. Every phase will be its own workshop, right? So people don't have to commit to a long 6-month program. Anytime the workshop is on, and you guys can just log in and take that small 1-week workshop, finish that in phase by phase, and then move towards your career transition. So next we come to deep learning, which is like an extension, a different way of doing predictive analytics. This is completely a domain in its own, and there is a broad argument about where the AI field is going. You are going with deep learning. So invest a lot of time in deep learning. Invest in AI, machine learning also, because without machine learning you will not understand what deep learning, how it is doing it. But directly going to deep learning is not advisable. You will never get anywhere. Okay, so we also go with that phase. Most important after you learn anything is build something. Really build. When you are building something, trust me, people are waiting for you to build something. Whether you are just 3 months into data science, you go to your college. You go to college and say, sir, give me all the placement data from past 20 years. I'll tell you what kind of people will get placed. So once the college knows what kind of people get placed, the college will know, okay, these kind of courses are required. And what kind of students, or what was the marks of the students who got this kind of a job. So you kind of understand, helping the data-driven decision making, the college itself, to get more insights. Everywhere data, I told you, everywhere there is data, there is an opportunity. Okay? You just need to know how to use it. It's It's like this example that if you know only how to use hammer, then everything looks like a nail. You'll just go and try to bang it, right? But once you start understanding that, hey, I know a hammer also, I know a spanner also, I know a ring spanner, I know a screwdriver, you have to evolve, you have to keep an arsenal. Then you will know, okay, this kind of a thing has to be applied here. So now the question is, how do you achieve this? Fundamental answer is honesty and integrity, a responsibility. If you think you're an educated person, you have a responsibility as a human to humanity for your community, because you are earning a degree. A degree comes with a responsibility, a stature on its own. So that means that you are now bound to, I'm not saying free. I'm not saying you have to give free to the world. I'm saying charge, but make sure that you are a professional. Because it's not that people want free, or the world just wants you to work for nothing. The world is ready to pay, but somebody who's really a professional, because the world just wants their problems to be solved. So it is your prerogative to learn the right stuff and be at the right time and keep working on it as a discipline and like a responsibility that you take. You're an electronics engineer, you take up responsibility that I am an electronics engineer. It is my business to know about it, right? Like a data scientist, every field, right? It's a responsibility that you have to take. So that is how, once you take that integral responsibility on your own, and of course everything is clear, you will have the discipline, you will have the josh, motivation to do it, right? Next, after building a capstone project, which is like after build it, the next phase where the peripheral investment is happening is model deployment. Your model has to be deployed somewhere. Your model, if it's sitting on a laptop, is of no use. You have to put this model out on the cloud for people to start using. Maybe you'll put it out on the cloud or a server of your own college, where all the lecturers are connected to the LAN, and all the people are sharing the data. Data is keep on building it, and principal now has a new dashboard in front of him, which is like data-driven decision making, and they know what courses to invest, what kind of people not to take. Simply sometimes without knowing the right data, we reject some people, right? But the data start telling you that, hey, you cannot reject this person because he's got a low mark. Look at this, all the successful people in the past had got this much mark in math, but never cared about Hindi or some other language. I'm not saying we don't care about Hindi, because the vernacular languages, as it goes down, so we don't give much importance to something which is like moving away, right? So while I talked about the vernacular language, another important fact that we do differently in our teaching is, I'll come back to that. So model deployment. So after you deploy the model, you build a portfolio. Very important for somebody who thinks already they know AI, and if you have built the models, get to building your portfolio. Your portfolio is built on GitHub. Certificates, all that resume thing, it's gone. Nobody cares. Okay? People want to know what kind of code you've written, where is it stored. They want to review it. They want to know whether you've written some blogs. They want to read your blogs. They want to understand how you're expressing it, right? Any field, not just data science. Any field, this is the age of portfolio, age of GitHubs. GitHub is an online repository for all the codes. And even Kaggle has a repository. So you have to develop something and give it out there for other learners to learn. That's a portfolio. And of course, our phase 9 is the jobs, right? So as I was saying, that we have one of the important change in our method of teaching is we realize that the biggest issue, or why we are as Indians, or why we are not able to make that cut or boom in the technological era, especially when it comes to hard sciences like machine learning, AI and stuff, is because we have been learning math. We have been learning math and physics and all these related subjects in the language, English language. Okay? Although it is fancy, English becomes like fancy. Knowledge of English has become sort of fancy, right? But nature doesn't care in which language you learn. It only cares about logic. So what we realized in our team discussion is we can you can completely decrease the time of transition from 1.5 years to 9 months if we can teach the concepts related in the language which is more like a mother tongue. So for me, the language more connected with is I'm from Karnataka. So Kannada is the language which is like what I grew up learning, right? And of course, then I married a wife from North India. So to fight with equal intensity, I had to learn Hindi, right? So then with that in mind, so now I'm okay with Hindi also. I can give a lecture in Hindi. So we decided let's do some experiment. Let's do some experiment and try to teach a machine learning course or a programming course in Hindi. So we came up with that entirely new, different, fast track machine learning course and Python programming course just for those people who have fear of programming. So because it's interesting for us, we also want to do something different, right? So when you start doing different, there are different results. So you also want to do that. So there are all these options available. If anyone is interested, get back to us, let us know, and we can schedule these kind of programs for you. And as you can see, these programs are like because it's interesting to us and it's an experimental program, which of course once you've already done it and we've got great reviews, we have priced it at a giveaway price like $499 for 15 days fast track learning course and another $499 for a complete Python reprogramming course. All of that is there. So let us know if anyone is interested in joining this, right? You can let us know at this number. And thank you so much for this opportunity. I guess this is we've already crossed 10 minutes of the session, so I would say this is all I have for you today. There's much more, of course, for another 5 hours we can speak, but time is always, as you know, is the limiter, right? So thank you so much, guys. I mean, 80 members still, and we started with around 100 or 80 and still there. I'm so happy to see the same number still hanging around, and hopefully we have answered all the questions. Just look at the email IDs, learn@analogica.in. And I would also want to tell that we have a community, okay? We have a data science community on Telegram as well as WhatsApp. So if you guys can join there, then you will have direct answers, replies there, because it's a very active community where we have polls and stuff. So I'll send the link to Sachin sir. If you can message them the forward that I sent to all the participants, then anyone interested can join our community.
Okay, sir. Thank you, sir.
Thank you.
Any participant want to ask any question, please write in Q&A.
Sir, can you please unshare?
Yeah, I'll do that.
Thank you, sir.
If any participant want to ask question, please write in Q&A.
Questions? I think questions are done, Sachin sir. You can go ahead.
Okay, if the questions are done, so thank you, sir. Again, your talk definitely ignite the mind of participant towards data science.
Thank you, sir.
So now I move to the valedictory session.
Yes.
All dignitaries, Principal Dr. S.K. Naveen sir, organizing team, the most valued invited guests, and dear participants, it's my privilege to have been asked to propose a vote of thanks on this occasion. I am Sachin Bade, Head Department of Electronics, Nabira Mahavidyalaya, Katol, and entire organizing team. Let me call it fraternity of data science here together, and on my own behalf, extend a very hearty big thanks to speaker Mr. Vijay Shantagiri sir for his efforts and encouragement towards data science. Finally, I would like to take this opportunity to place on record our hearty thanks to Dr. Rajuji Deshmukh sir, President SPM Katol, and our principal Dr. S.K. Naveen sir for the perfect logistic support and guidance he has extended to all of us at webinar. I also extend my thanks to Dr. Adil Jivani sir, Atul Charde sir, Praveen Revatkar sir, Dr. Prakash Yavalkar sir, Dr. A.B. Sharma sir, Amit Vaidya, Roshan Barai, and all organizing team for their enormous cooperation in the organization of this webinar. Thank you very much to all who are directly and indirectly involved in this webinar. So all participants are requested to must fill the feedback form. The feedback form will active after the half an hour of this webinar, and it will active till the 5 p.m. today. You will get e-certificate after filling this form. And if any query regarding certificate, feel free to call me. Thank you very much to all once again. Now I declare this webinar is over. Thank you.
Thank you, sir.
Thank you, Vijay sir.
Thank you very much, sir. Thank you so much.
Thank you.
Nice meeting you all, sir. Hope you enjoyed.
Thank you. Thank you, sir. Thank you.